Okay, welcome back. So for this example, we're going to be determining the load that would cause the rod to exceed a certain ultimate strength or stress of 71,000 psi. So what we're going to do here is use the fundamentals mechanics of materials equations using the FE handbook 10.0. So for this question, we're told a steel rod in a given structure is 18 feet long and it is to carry a 7-ton load. If the elongation of the steel rod is limited to 0.075 inches, the modulus of elasticity for the steel rod is 33 million psi. The load in pounds would cause the rod to exceed its ultimate strength of 71,000 psi is most nearly what? So let's write what we're given. We're given here we have a steel rod. It's 18 feet long, 18 foot, and it has a 7-ton load. So this rod is carrying at that moment in the structure a 7-ton load. So let's write that as a load, and it's going to be denoted by RP here. It's going to be 7 ton. And we know the elongation of the steel rod is limited. So this is our elongation. It's going to be 0.075 inches. And the modulus of elasticity is 33 million. So it's 33 times 10 to the 6. We have 6 zeros. And it's in PSI. So automatically I notice PSI is pounds per square inches. I need to convert this feet to inches. So we can quickly do that. We know 1 foot is 12 inches. So you take 18 times 12. So I got 216 inches for the length. This ton has to also be converted because we know we need pounds. This is the elasticity, the modulus of elasticity is pounds per square inches. So to go from ton to pounds, we're going to refer to our FE handbook. And let's go to the units and conversions. Go down. This is the new handbook 10.0. And I think the ton, yes, so it's here. We can go from ton to pound force by multiplying by 2,000. So I'm just going to simply, if I go back to my slide here, I can go simply multiply 2,000. So I just take the 7 times 2,000 and it's going to be 14,000 pounds. So we have that. Then we need, I think that's all we're given for that portion. But what we're trying to solve is for the load in pounds that would cause the rod to exceed the ultimate strength of 71,000 psi. This ultimate strength is going to be our sigma, or stress. So it's 71,000 psi. So what we want to find is the load P at 71,000 psi. So what we're going to do first is find the area for the structure at these given conditions. So it's in a structure, it has a 7-ton load, and it has the following modulus of elasticity and that particular length of 18 feet, which is 216 inches. So we're going to find that area. That's going to be our first step. Step 1, find the area. Then our second step would be to find our load here, our load P, using that specific area. So we will find the area first, and we can refer to the handbook and use the modulus of elasticity equations. And it's going to be one equation. If you go to the mechanics of materials section, you go down and it's going to be this equation. So from this equation we can find the area given the modulus of elasticity, given that 7-ton load, given that length, and given the deformation. That was step 1. Then we can find the actual load for a stress on ultimate strength of it was 33 million psi. No, I'm sorry, it was 71,000 psi. Yes, for that stress. So let's find the area first. So if I extract that equation, we know that elasticity, the modulus of elasticity, is going to equal to the load divided by area. So this load is the 7-ton load, right, for the structure. And we have the deformation divided by the length. If you rearrange the equation, the area is going to equal to the load times length divided by deformation times modulus of elasticity. So the area, what's the load here? It's the 7-ton, so it's 14,000 pounds. We converted that. 14,000 pounds. The length is going to be 216 inches. Then the deformation there is 0.075 inches. And the modulus of elasticity is 33 times 10 to the 6 psi. So the units all look good. We've converted what's needed. You can solve for the area here, and you should get around 1.22 inches squared. So we're not done yet. Now we need to move on to step 2, which is find the load at that ultimate strength. So we're asked, if we go back, it's the load to exceed the ultimate strength. Once we hit this load, we've exceeded the ultimate strength. We've essentially hit failure. The ultimate strength, our sigma, here our stress, our ultimate stress is 71,000 psi. So if you go back to the equation, we're just going to use that. We're going to solve for P here. So going back, our P equals to our sigma times A. Our sigma ultimate strength is the 71,000 psi, right? So you plug in 71,000. PSI is pound per inches squared. And the area, we're going to use that same area, 1.22 inches squared. These units cancel. We can solve for the load, and the load is about 86,600 pounds. So this is our answer, and it's going to be C. And that's all. Don't forget to subscribe and like, and thank you.